Okay, so today we're going to learn about volume. Think about air for a minute. It's all around you. You breathe it all the time, but what is it? Is air a type of matter? Does it have mass and take up space? In this lesson, you'll be examining the property of matter called volume, the ability to take up space. You will become more familiar with the metric units of volume and examine the laboratory equipment typically used to measure this aspect of matter. You will then investigate different ways of measuring the volume of various objects. Okay, so converting between units of volume. The amount of space that matter takes up is called volume. Any unit of matter, large or small, solid, liquid, or gas, takes up some space and therefore has a volume. This means that air is a type of matter. Liquid volume can be measured using a base metric unit called the liter. The base metric unit for measuring the volume of a solid is the cubic meter. Because you are dealing with the metric system, the other units of volume use the same prefixes as those used for length. The conversion process is also exactly the same. So, you are probably familiar with a few everyday items that are measured in liters. For example, sodas are often sold in liter or 2-liter bottles. Okay, so they're saying they want you to convert 40.2 liters to millimeters. Now this is kind of like what we did in the other section, okay? They got liters and milliliters. So just like we had meters, we had decameter, hectometer, kilometer. Now we're talking about liters. This one right here. And liters are what we measure liquids, okay? The volume of liquids is measured in liters, like the soda we talked about. Okay, so they want to convert 40.2 liters, which is our base unit. That's our number one spot right here, liters. We want to convert it to milliliters. So milliliters are all the way over here. So when they say make a metric line, they're talking about pretty much making a replica of this box right here. You've got kilometer, there's your kilometer right here. Hectometer, got your hectometer right here. You got your decameter, there's your deca. U is where you're at, is like your base measure. It's the ones place. And then you have decimeter, centimeter, or in this case, centiliter, and milliliter, okay? Milliliter right here. So put your pencil on the prefix of the given measurement. So they gave us liters, okay? So liters are right here. So that's going to be right here in the middle. Put your pencil on the prefix of the given measurement and count the number of spaces you must move to the left or right to get to the prefix of the desired conversion. Okay, so it's saying how many spots do you have to move to get to milliliters, okay? So remember, the M stands for milliliter, which is right here, milliliter, okay? So we're starting here in the middle, and we're gonna get over here to milliliters. So we gotta shift 3 places. 1, 2, 3. 3 places to the right. This is where we started, 40.2. This is where our decimal point is now. But, so we just take that decimal point and we move it over 3 spaces. 1, 2, 3. And now we have these holes right here. You're gonna fill the holes in with zeros, okay? And now your 40.2, now that we added these zeros, is now 40,200 milliliters, okay? So we can conclude that 40.2 liters equals 40,200 milliliters. Okay, measuring the volume of liquids. Liquid volume is often measured using a graduated cylinder, which is the shape of this object in the picture. To get precise results, you must be able to read the scale on a graduated cylinder. which generally lists gradations in milliliter units. When measuring the volume of a liquid, take the measurement at the lowest point of the curved surface, the meniscus. Look at the figure below. Okay, so right here is our graduated cylinder. This is our curve. The lowest point right here. This is also called a meniscus, okay? This curve is called a meniscus. And you want to take the measurement at this point right here, the lowest point. You don't want to take it over here. You don't want to take it there. You want to take it right here where your measuring lines are. Okay, so what we're going to do now is we're going to look at this graduated cylinder. Okay, and it tells us, it wants us to read the following graduated cylinder. It wants us to figure out how much is being shown in this picture. What is the volume of the liquid shown in the picture? So we click to zoom, and we can see that, okay, 40, the 40 mark is actually this big mark right here. This is where 40 is, okay? And then we have 41, 42, 43, 44, 45. So this mark right here, this bigger mark, that is the halfway mark. And then we got 46, 47, 48, 49, and 50. 50 is this big line right here. So there's 10 little dashes in between each reading, okay? Between the 40 and the 50, there's 10. So it wants us to figure out where is this little meniscus at, okay? So we know this is 45, this is 46, this is 47. And then that's 48. And it looks to be a little bit above that 47. So we could say that this measurement is maybe, let's see, 46, 47, maybe like 47.1, 47.2 maybe. It's not halfway between the 47 and the 48 mark. So it's like maybe 47.1, 2, or 3. Okay, it says the proper reading for this volume is somewhere between 47 and 48 milliliters. Because there is a marking for exactly 47 milliliters and exactly 48 milliliters, you must estimate where the measurement actually falls by adding one more digit. Estimates will vary, but the reading should be approximately 47.2 millimeters. Okay, and it's just saying, remember, we're reading the bottom of that meniscus. Remember, this is the meniscus, and we're taking the measurement from the lowest point of that meniscus right here. Okay. Measuring the volume of solids. So we just talked about liquids, now we're going to talk about solids. The units, scales, and tools described above will help you determine the volume of an object. Remember that the volume is the amount of space the object takes up. You can determine volume in the following two ways. Okay, if an object has a uniform shape with linear sides, I'm talking about like a box, okay, linear sides, a box or a rectangle, like a shoebox or something like that. Okay, if the object has a uniform shape, linear sides, or a common geometric shape, like a block of wood, a brick, or a cylinder, you can use the formula method to measure the object and determine the volume mathematically. For an object with square sides, the formula volume equals length times width times height can be used. It also looks like that, V equals LWH. When the letters are together like that, LWH, that means they're multiplied. Remember that the unit of measure is the answer. It will be cubed. Okay, so example. Determine the volume of a box. Okay. With a length of 14 centimeters. There's your length. A width of 11.5 centimeters. That's the width right there. But I put the wrong measurement. I'm sorry, that was supposed to say 11.5. And a height of 9 centimeters. Okay. How do you get that? You have to do length times width times height. Okay. Length times width times height. So right here, we've got our length. They told us it was 14. So we put our 14 here. We got our height, which is 9. We got our 9 right there. And we got our width, 11.5, which is right here. And remember, when numbers are side by side, separated by parentheses, that indicates you're going to multiply. So this is 14 times 11.5 times 9. And when you multiply those three numbers together, you get 1,449 centimeters cubed. Okay. For an irregularly shaped object that cannot be measured easily or does not consist of uniform geometric shapes, like a horseshoe or a blob of silly putty, you can use the water displacement method of measurement. This is done by partially filling a graduated cylinder with water and recording the initial volume of the water. The object to be measured is then carefully placed in the cylinder, causing the water level to rise, and the new volume of the water is recorded. By subtracting the initial volume from the final volume, you can determine how much water was displaced. The volume of water displaced equals the volume of the object. The water displacement method will not work with anything that dissolves or absorbs in water. So remember that. Okay, so here we go. Think about it. Have you ever dropped something into a full pail of water and seen some of the water flow over the edge of the pail? Whatever was dropped into the pail took up some of the space that had been occupied by the water. As a result, some of the water was displaced from or pushed out of the pail. Water displacement occurs because no two units of matter can take up the same space at the same time. Okay, so let's go to the next one. All right, expressing liquid volume in solid terms. As mentioned earlier, the standard unit of measure for liquid volume is the liter. The size of the liter is actually determined using linear metric units. A liter size is expressed as 1 cubic decimeter. A cubic decimeter is 10 centimeters long on each side. If you were to fill this cube over here with a liquid, it would hold exactly 1 liter or 1,000 milliliters of fluid. The relationship between the liter and the cubic decimeter illustrates how liquid volume can be compared to and expressed in terms of solid volume, and vice versa. For example, suppose you use the water displacement method as described above to determine the volume of a rock. You obtained the following data. Okay, so let's say you had a cylinder with water in it, and the cylinder started off at 22.4 milliliters, okay? Then you added the rock to the cylinder. Now you have a measurement of 36.8 milliliters. The change in water volume is the difference between these two numbers. So 36.8 minus 22.4 is going to give you this change in water volume. So that's 14.4 milliliters. So the volume of the rock is 14.4 milliliters. Does it make sense to say that the rock has a volume of 14.4 milliliters? No, absolutely not. Milliliters are for fluid. But you know that 1 milliliter equals 1 centimeter cubed. So to translate this, you would really say that a rock's volume is expressed as 14.4 centimeters cubed, which is basically the same thing as 14.4 milliliters. So reporting the volume of the rock in cubic centimeters is much more appropriate. Okay, did you know some fields, such as medicine, use cubic centimeters for fluid measure? I did not know that. Okay, so that is time to review. So, to sum it up, we've learned that the basic unit of liquid volume in the metric system is the liter. It can be easily converted to smaller or larger units using the metric prefix line, which it's talking about this thing, the KHD. This is where the U was, or sorry, that's a DK, a DCM, okay? You have learned that when reading the volume of liquid in a graduated cylinder, you must read at the bottom of the meniscus, which is the curve of the water, and estimate 1 digit beyond the smallest gradation. To determine the volume of a solid with a regular shape, you can use geometric formulas such as volume equals length times width times height. If the object has an irregular shape, its volume must be determined by a process called water displacement. When measuring the volume of a solid, you should record the measurement in cubic centimeters, not millimeters. Okay, now you're going to answer some questions based on this information that we went over.